Hello Techers! Welcome back to episode 8 of the basic Arduino series, and in this episode I'm gonna be teaching you how to make an automatic night light where when the surrounding light becomes dim, this light will automatically turn on, and if there's light around it, it would stay off. We're going to be using an LDR, which is a light detecting resistor. And yeah, that is basically it for today. So let's get started. Okay, so for the wiring, it's mostly simple. There's just a little tricky part that I'm gonna be explaining. Okay, so first of all, let's just keep it simple and start with the lamp. Okay, so the LED, just as we connect a normal LED, we take an LED, we put the positive pole like on the right side and the negative one on the left side. Okay, and then from the left one, we just take a wire to ground. However, since I need two grounds, so I just took here, you see the ground here, I just took a wire from it and then put it all the way on the negative rail on the breadboard, and then whenever I need any ground I could just connect it here. So I take the wire from the negative side of the LED and just put it on the ground rail here, and on the positive side I took a 220 ohm resistor and just connected the gap between it, like just over the gap as if it's a bridge. And then from there I took a wire. Well, I like to choose a wire that has the same color as the LED I'm using so that it won't be tricky. Okay, so the white wire goes from the other leg of the resistor to the pin that I used. I used pin number 3. Okay, and basically that's it for the LED. Very simple. However, for the LDR, which is the light detecting resistor, so the two legs, there isn't a positive one and the negative one, they're both the same. So we take from one leg, we take a wire and then we insert it 5 volt here. You see the 5 volt here, 5 volt pin, we just insert it here, and that's it for the first leg. That's it. For the second leg, we put a wire and then we take it all the way to the analog pin that we're going to be using. I used A3 so that it would match with my digital pin, A3 and 3, that's it. And then from there I do like a bridge with this resistor. It is 10 kilo ohm, okay, it's 10k ohm. Okay, so and then from this part of the wire I just take the first leg and make it across there, and then from the other leg I'm going to be taking a wire and then putting it on the ground rail. So it's basically, for the first leg, a wire to 5 volt, and then for the other leg it is gonna be wire to the analog pin, and then one leg of the resistor over the gap of the breadboard, making a bridge, and then other leg of the resistor, just take it all the way to the ground rail, and then that's it. That's basically it. And yep, take a good look at it, and that's it. Code, it is only a few lines. So first we start with our variables. So we start with int, and then we name our variables. We're gonna have two variables, the LED and the LDR. The LDR is the light detecting resistor. So integer and then LED equal. So, and then you write for the specific pin that you chose. In my case, it is going to be pin number 3, and then semicolon, and then another int, LDR equal, and I chose A3, and then another semicolon. Okay. However, for the surrounding light, our variable isn't gonna be, the light that it's gonna check the value of every single time. We're not gonna be writing it here. We're gonna write it in the void loop, since the void loop repeats the code once like everything is done and so on. It just repeats the code. However, if we wrote the variable up here, it wouldn't go back to it and then check the value once again. However, if we wrote it in the void loop, it's gonna check the value every single time the code is looped. That is why for that variable, we're gonna be writing it in the void loop. So now for our setup, we're gonna be putting only for the LED. The LDR does not need any setup. Okay, so we write pin load. Okay, open parenthesis, and then we need LED, and then just output the normal way. Okay, and then we put this. Okay, and then for the void loop, we're gonna first put the variable for the surrounding light. So we write int, and then you can call it whatever you like. You could like call it light value or whatever you would like. Okay, so it's gonna be surrounding. I don't really know if this is the right way to like write surrounding, but it's okay. Surrounding light, and then it is equal to analog read, since we had the LDR connected to an analog pin and not digital pin, so we're gonna have it with an analog read. Analog read, and then just end it with a semicolon, just like this. Okay, so we forgot a very important thing. We forgot to put LDR, like for the resistor. Okay, and then we put the semicolon, and now we start with our if-else condition. So we're gonna write if the surrounding light is higher than a specific value, then the LED won't have to turn because there is light surrounding it. However, else, which means that if the value did not reach up to what we said, which means it's dim around it, thus it's gonna light up. So we need the if else. Okay, so now we write if, we open our parenthesis, and then we write surrounding light, and then we issue it to be greater than 500. Okay, and we do not need to put a semicolon after the if. Okay, so we go down. Okay, so now we do shift and then open our curly braces. We write digital, right? Just normal. Now we're going to be working with the LED. That is why we wanted digital, right? Okay, digital, right? Then we open parentheses, we write LED, then this, and then we write low, because we want it to be off if there is light around the LDR. And then we go down here, and then we write else, and then just go down, open another curly braces, and then write digital, right? We want the LED to light. Okay, so LED high. Okay, and then out, and then a semicolon. And then we want it to delay its action. Like, we don't want it to like directly do whatever stuff. It wouldn't like feel smooth or whatever. So we're gonna just do a delay just for 200 milliseconds. Like, it's not that much. Like, it's 0.2 seconds. Okay, and then a semicolon, and this is it for the code. However, I'm gonna like show you something. I'm gonna write something for you. which is gonna help you open your serial monitor, which is gonna like show you the value of the light that the LDR is actually detecting at the moment, okay? And it like detects like multiple values each second, okay? So let me show you. You go to the setup and then you write serial and then dot begin as it begins from here, and then we want 9600, which is I suppose the highest value it could take or whatever, okay? And this is it for here, and then we go here. Look, directly between the variable and for the surrounding light and the if and else, okay? Like in between you write serial print. I wanted you to write it there so that you wouldn't confuse yourself. Oh my god, where I have to write it or no? No, I just tell you where to write it. Okay, we want print line, but we're gonna like write the line with ln instead of writing the whole word. So ln, print line, and then surrounding light. Thus, it's gonna like print the surrounding light for us, the value of the surrounding light. And yeah, that is it for now. Okay. Okay, so now we compile our code and then we put it. And for you to activate the serial monitor, you just go to Tools and press Serial Monitor. It's in the fourth line, okay? And then it started connecting values. So as you can see right now, the value is very low. That is why it is supposedly lighting here. And yes, it is lighting in the hardware. However, as you can see, when I moved away, my shadow is gone and there is no more light on it. For today. However, Don't when forget I to put like my and shadow subscribe for more back, Arduino made simple. it starts lighting. So now that my shadow is stable, it is fully lighting. And look at the value at the serial monitor, it's always lower than 500. And now I move. Oh my god, my shadow is still there. Okay, now that I move away, the serial monitor is having the value more than 500, so it is not lighting.